Hey guys, in today's video we're going to be enabling input shaping in mainsail clipper on this Ender 3 Max Neo. I'll show you guys how to wire up the ADXL345 to BIGTREETECH CB1. We'll run some resonance tests and I'll show you guys the before and after prints. Guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. All right, let's get the printer up on the bench and we'll get to work. All right, so let's start by taking off the Raspberry Pi cover. Looks like this thing came loose. Stick that back down there. All right, and we need to pull this thing out of here. So this is the little connector that we're going to use. Straighten this out. Makes me crazy when things are not straight. All right. Okay, so it looks like this might get a little tight here maybe. All right, so here's the plug that we made up. And we're only going to use this one side, this one row. And what we're going to do is we're going to have to count the 8th pin. So pin number 1, get you closer so you guys can see what's going on. So on this CB1, pin 1 is right here. So this first inside pin is pin 1. So we're going to count 8. 1, 2, 3, 4, 5, 6, 7, 8. So the 8th pin is the one where it's going to have our first connector. And the first wire that we're going to have is the white wire. Let me get this thing in focus. And the white wire is the CS wire on the accelerometer, on the ADXL345. And I'll put up a diagram on the screen showing how this thing needs to be connected. Let me go ahead and mark off this thing here. So I gotta count it again because I lost track of it. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's the one that lines up with this thing here. So let's see, like this. All right. And now what I'm going to do is I'm just going to route this wire somehow. To the outside. And let me bring this thing back a little bit. want to tape the end of this wire protector here so that I can make it a little bit thinner so I can get it through this opening easily. Just like that. And I gotta fish it under here somehow. I think I'm going to do is I'm going to stick a set of tweezers in there to try to grab it, guide it. There it goes. All right. Okay, and I'm going to go ahead and put this cover back on because we don't need to do anything else in here. And the last screw up here. All right, guys, I'm going to solder up this end here real quick. And all I'm doing is, so here's the end of my accelerometer cable. And all I'm doing is matching up the colors with the colors that are on these, on the other side of the wire. So this thing goes like this. So I'm just going to solder up the white wire here, green wire, red wire, orange wire, yellow wire, and then finally the black wire. So let me do that off camera real quick. I don't want to bore you guys to death with my soldering. And then we'll fasten it down here and do some resonance testing. Okay, now after we got the wiring all done on the inside, let's plug in the accelerometer and do a query to see if it shows up and it's communicating with the CB1. So you can just plug it in and just leave it loose. Let's head over to the computer and I'll show you what you need to do. All right, let's jump over to our clipper session. And in here, what you want to do is, I made a document. So let me show you that document real quick. So this is kind of like an ongoing project. And what I added here is, if you're installing the accelerometer on a Raspberry Pi 3B, this would be the format that you would follow. So the wiring and the GPO pins that you're going to need, along with mounting options and instructions on installing the software to the Raspberry Pi. But if you're going to install this on a CB1, it requires different instructions. So I included a section here for the CB1. So here you have the diagram. So starting with pin number 1, which is this first inside pin. And then the wiring for the ADXL345 starts at pin 8 and finishes at pin 13. The instructions on enabling the software are below. And it's beneficial that you do this prior to your first boot, because you'll be able to access the files in the root directory easily. Once you boot it, it's more difficult to go in and change this. So make sure that you do that prior. And then this is all you need to add. So you go into that boardenv.txt and add the following lines. Save the file. And then once you're in Mainsail Clipper, you open the wrench icon, go to your printer.cfg, and you enter the following information below. Save and restart the firmware, and if you don't get any errors, then you should be good to go. So this is the line that we're going to use to query the accelerometer. So we can just copy this, right click, copy, and then go over to the Clipper session, and in the console, you're going to right click and paste it, and then you're going to send it. And you're going to get a response back from the accelerometer. It should look like this. If you don't get any response back, check your wiring and make sure that your wiring is correct. And once you're done with that, let's go ahead and do our resonance testing. So we can go back to the original document and go to the next page, which is page 33. And we're going to select this first line. But before we do that, we got to mount the accelerometer to the print head. So let's go ahead and do that real quick. All right, guys, since I have the accelerometer already connected to the adapter for the Garolite, I'm going to go ahead and just do that test first. And all I'm going to do is just push it on here. Make sure it's in the center. And I'm going to support this cable, so I'm just sticking the extra cable underneath. You see that? I just put it underneath so that this is kind of supported. And leave yourself enough room because we got to home the printer first. So that should, let me see, make sure I left myself enough slack. Yeah, that should be good. All right, let me go ahead and home the printer. Okay, let's head over to the second page and let's start with shaper underscore calibrate axis equals Y. So just right click, copy it. Head over to the Clipper console, right click, paste, and send it. One thing that's very important when you're conducting this test is to make sure that the printer is located in the area where it's going to be printing. Make sure it's on a stable surface. That way you get the most accurate resonance frequency values. Once it's finished giving you the values, it's going to give you the option to save. So you want to make sure that you copy the save underscore config. Right click, copy it, paste it into the console, and send it. It's going to restart the firmware, and then we're going to pick up on doing the X value. So one thing that you want to do before putting any metal tools near the probe is let's unplug it. So I'm going to unplug it from the port here on the printer. And now we'll just take it off of here. Unscrew it from the adapter and put it on the tool head. Alright, once you have it on the tool head, make sure it's nice and steady. And remember, we got to home the printer again. So go ahead and plug in the accelerometer. All right, the same thing as before, just try to get this cable out of the way so it's not causing problems. So just kind of have it hanging here, but it's not touching anything. And now we're going to grab this next one, shaper underscore calibrate access equals X, copy, paste it into the console, and send it. All right, same as before. Select save underscore config. Paste it and restart the firmware. All right, now that that's done, let's go ahead and unplug the sensor again. And we're done with it. We're not going to need it anymore. Okay, now that we got our values all saved, let's go into the printer.cfg. And let's scroll down into the saved config information. And down here we got our input shaper values. So let's select this, copy it, and let's open a notepad and paste it in there. Okay. We exit out of this. Go back to our, actually we need the console. Click on the console and let's take a look at the testing parameters here. So let's go to the first one, which was the y-axis. All right, and what we want to look for here is the value that is in our printer.cfg. So if you look here in this little notepad file, let me set it so that it's always on top. It's assigned a an input shaper method called EI, and frequency is 33. So what we're going to look for in here is EI, so it's right here, EI, and the frequency is 33, and it says to avoid too much smoothing with EI, suggested max acceleration is 2000. Okay, so we're going to write this down here. Let's tab over a couple, 2000. All right, now we want to look for the next one. So to find the next one, we got to scroll up because it was the last test that we did. And it's assigned a testing method of MZV. So we're looking for MZV right here. And the frequency is 98.6. And again, it says to avoid too much smoothing with MZV, suggested max acceleration, 28,600. Now, this would be great if the 28,600 could be applied to the Y as well, but we can't. So we have to choose here, okay? Now, what I suggest is to choose the lower value, even though it's not, super fast or anything. So let's copy this, go over to our machine icon, printer.cfg, and we're gonna scroll down here toward the bottom. Okay, here it says max acceleration is 3,000. We're gonna change this to 2,000. All right, so once you got that value in there, let's save and restart. And let's head over to the printer and we'll print a test file. Now, I had printed this thing before. It came out real lousy. We'll reprint this part. Alright, our part is done. Let's check it out. Alright, so here's the first one that printed prior to us enabling input shaping and measuring the resonance. You can see it's got a lot of artifacts. Kind of hard to tell from this angle, but you can see it right there. See all those extra lines? Yeah, it's not supposed to look like that. Okay, so let me show you the other one. So this is the one that we just took off. You can see how it doesn't have the same ringing artifacts like the one on the left. Anyway, so yeah, it works. Look at that ringing. Nasty. And it looks like the ringing is real bad right around where where this seam is. See that right there? So right after that seam, you got a bunch of ringing there. And here's the same seam right there. And no ringing. Alright guys, if you're new to the channel, consider subscribing. Turn on your notification bell. And leave me some comments. I love reading the comments. And do my best to get back to you guys as soon as I see them. If you guys are interested in the G10 for the Ender 3 Max Neo, they're currently in stock on Amazon. I'll leave a link to all that in the video description, along with the adjustable bed probe. Alright guys, I'll see you guys in the next one. Take care.